শুনতে পাচ্ছিস আমার কথা?
হ্যাঁ স্যার, শুনতে পাচ্ছি।
পূর্বী, এক মিনিট। আচ্ছা দেখ, যে last day we have discussed about the general properties of modern periodic table. Okay, some characteristics of modern periodic table. Today we want to discuss the periodic variation of different properties. Like first of all we should discuss about the periodic variation of atomic radii. There are some important informations. The elements of group 1 and 2, that is the groups present in the left hand side of the periodic table, that is first one, that is alkali metal, and the second one is alkaline earth metal, and the other p block elements, those are present in 13 to 18 group. All those elements are known as main group elements. They are also known as the representative elements because they have common characteristics in their particular group. There are some elements are present, those elements having common characteristics of other elements present in that particular group. For example, if you consider lithium, sodium, potassium, rubidium, cesium, and francium, period 2 and 3, these elements, they having common property with respect to the other elements. But first of all we should discuss about the main group elements. Main group elements means the elements present in S block, that is the elements in group 1 and 2, and the elements in P block except hydrogen. If you we do not consider hydrogen as the main group element. Now second period elements except inert gas, they are known as the typical element. Typical element means second period elements shows those properties which are very common to the different elements. That's why they are known as typical element. Typical means they shows the general properties of the elements. There are no different exceptional effects in those elements. Now the other groups like group number 11, the elements like copper, silver, and gold, those are known as coinage metals. And the elements, those are present in 3 to 11, the middle part of the periodic table, that those are known as transition elements. Those elements are present in the middle part of the periodic table. Previously we have shown those middle part of the periodic table, that is from group number 3 to 11. One side of that particular group is S block and other side is P block. One side is metal and other side is non-metal. Now S block and P block, those elements, generally we have already discussed that those elements are known as representative elements. Transition elements, they have stable oxidation state. Oxidation state means the valency state. Those are known as transition elements. And the inner transition elements, they are outermost shell, not only outermost shell field, but also the inner shell, that is the penultimate shell and anti-penultimate shell. The outermost shell is known as the valence shell. But in case of inner transition elements, if you consider inner transition element, then the outermost shell as well as some inner cells are filled at a time. That's why they are inner transition elements. Like n-1 cell, n is outermost cell, n-1 cell, that is the penultimate cell, and the other cell is anti-penultimate cell. Now if you consider, this one is valence cell, this one is penultimate cell, and this one is anti-penultimate cell. All those elements filled at a time. These elements are known as inner transition elements, and there are two types of elements, inner transition elements. One is lanthanide and another one is actinides. So these are some general informations regarding the modern periodic table. Okay, now next we consider some of the atomic number of the noble gases like helium, neon, argon, krypton, xenon, radon, and they have like 2, 10, 18, 36, 54, and 86. All those elements are known as the noble gases, or you can consider them as the inert gases only because of the fact that they having closed cell electronic configuration. They do not take part in the chemical reaction. Generally, they do not take part in chemical reactions. And those elements are, all the elements are present in the atmosphere, though very small amount, but they have some valuable uses, and these elements are known as inert gases: helium, neon, argon, krypton, xenon, and radon. Now the elements in the periodic table, how they are named? They are named, some of the elements named according to the name of some scientist, according to the name of some planets, Greek mythology, or the place of discovery, or some elements having their behavior. For example, if you consider the element americium, this element has been named. This is discovered in America, and that's why it is named as the americium. Another one, that is a planet, according to the planet named Mercury, according to the planet name, and scientists like borium, Rutherfordium, curium, mendelevium, etc. There are so many number of elements. Those are named after scientists. And the behavior hydrogen, it is a water forming. Hydro means water forming, so hydrogen is responsible for the formation of water. That's why you can say that hydrogen as the producer of water. So the elements may be named in this way, but according to the UPAC system, International Union of Pure and Applied Chemistry, they consider some roots for the different digits, and the elements greater than that of 100 should be named according to the IUPAC nomenclature. This system starts from 1964, when a particular element, that element having named after Rutherfordium, and also it is named by Russia as Kuchatovium. So there is some problem arises that same element is identified by America, discovered by America. They claim that they discovered this particular element and they named it as Rutherfordium, when Russia also claimed the discovery of this particular element and they named as Kuchartovium. So the same element having two different names, and uh, in order to remove this controversy, the UPAC system, UPAC organization, they uh, think about this particular fact that they should name a particular element after the discovery, unless and until it is proved by discovered by which particular country or which particular scientist. Unless and until this is proved, the element should be named by UPAC organization. The UPAC developed some rule. That rule is the different digits, like you see that here the digit 0 is named as nil, 1 as an, 2 as bi, 3 as try, in this way. And the ninth digit is known as ENN. So how we should uh, how we should give the names of different elements, like if you consider that 101 number element, what is the name of this particular element? Also the symbol, it is 1 means an, and 0 means nil, and again an, nil an yam, that is the name of 101 number element. In this way you can name the different elements according to the UPAC system of nomenclature. Like here you see that 107, so the UPAC name will be an, 0 means nil, and 7 septium. U stands for U1, an, and nil, in, and UN, S, septium means S. So the initial digits of this root, that should be taken as a symbol. Now here you see that 110, that is the name of this element will be an, and 0 is anilium, anilium, UN. Like 118, that will be an octium, octium means so. 135th element, it is not discovered, not yet discovered, but when discovered, then the name is already fixed, that is an tripent yum UTP. So in this way, is it clear to you, all of you, the UPAC system of nomenclature?
Yes, sir.
Yes, sir.
Okay. So this is the UPAC nomenclature system, and also the symbol of the different elements. Those will be assigned according to the UPAC system of nomenclature. Now we come to the next important point, that is the trends of the different properties, like atomic radius, ionization enthalpy, electron gain enthalpy, etc., all those properties, the trend of those properties in the periodic table. Now trends means the change of those properties as we move from left to right or we move down the group. Now first of all, some important aspects of these periodic properties, that is, what do you mean by periodicity? What does periodicity actually mean? The periodicity means the reoccurring of the certain properties after a definite interval. Like, for example, you can take as an example that we write some of the oxides of different elements in the second period. Like, second period, not you can use third period. Usually, sodium oxide, Na2O, MgO, Al2O3, silicon dioxide, phosphorus pentoxide, sulfur dioxide, Cl2O7. Here we write some of the oxides of third period element in order to explain what is periodicity actually mean. The sodium having sodium oxide, magnesium oxide, aluminium oxide, silicon dioxide, phosphorus pentoxide, sulfur dioxide, and chlorine heptoxide. Now, if you consider the acid-base property of those oxides, now what happens? Sodium oxide is highly alkaline. Now, magnesium oxide, it is considered to be alkaline. Aluminium oxide, it is amphoteric. Now, amphoteric means it contains both the character. It behaves like acid with base and behaves like base with acids. Those type of species is known as amphoteric. Now, silicon dioxide is very weakly acidic. Phosphorus pentoxide, it is acidic. Sulfur dioxide is strongly acidic, and chlorine heptoxide is very, very, very strongly acidic. Now again, when you take potassium oxide, then it will be again highly alkaline. So the change of property occurs gradually. There is no such cases where the one compound is highly alkaline and next to that highly acidic. Not like that. The changes gradually. Like sodium oxide is highly alkaline, after that amphoteric, weakly acidic, then acidic. So the periodicity means there is a change of properties, change or variation of the properties and reoccurring. Again, if you see that this is very strongly acidic, and after that potassium oxide is again that is similar to that of sodium oxide. So with the increasing atomic number, the properties are changing with a gradual change. Now, gradual change means the slight changes with the different properties and the reoccurring after a certain interval. That is the sodium oxide, again potassium oxide, or again rubidium oxide. In this way, you can consider the what is periodicity actually means. Periodicity means periodic. Periodic means the reoccurrence of the properties, reoccurrence of the similar properties after a certain interval, after the end of a particular period. If you do not consider the inert gases, because inert gases are not belong to this particular change, they are widely different characteristics with the other elements. That's why you can't consider inert gas elements because they do not form oxides like other elements, and they do not generally form the compounds. That's why you can't compare the inert gases with the other elements. So group number 18 should be left aside and compare the other elements. Now, what is the cause of periodicity? Why the periodicity appears? Now, for example, if you consider a particular group, that is lithium, sodium, potassium, rubidium, cesium, in this way. Now, lithium having electronic configuration 2,1, sodium having electronic configuration 2,8,1, potassium having electronic configuration 2,8,8,1, rubidium having 2,8,18,1, and in this way 2,8,18,18,1, in this way. So if we consider those elements, those are placed in the same group of the periodic table, all those elements having similar chemical and physical properties. Similar, not same. Similar chemical and physical properties. Now, what is the cause behind it? The cause behind it is the outermost cell electronic configuration. Outermost cell electronic configuration. Here you see that all the elements contains only one electron in their outermost cell. It means that only electrons present in the outermost cell, they can only take part in chemical reactions. So because of the fact that they have similar outermost electronic configuration, then they behave similarly. Not only this particular group, but also if you consider any other group like halogens like fluorine, chlorine, bromine, iodine, here you see that 2, 7, here you see 2, 8, 7, here you see 2, 8, 18, 7. In this way, all the elements contain 7 electrons in their outermost cell. So, the elements in a group having similar chemical and physical properties only because of the fact that they having similar outermost electronic configuration, reoccurrence of the similar. So cause of periodicity is the reoccurrence of similar electronic configuration after a certain interval, after the end of that particular period. So this is the cause of periodicity. Cause of periodicity. Now we consider some periodic properties of the elements: atomic radius, ionization energy, electron affinity, electronegativity. There are so many periodic properties, but only those properties like atomic radius, ionization energy, electron affinity, electronegativity, and metallic, non-metallic character, those belongs to our syllabus. That's why we should consider the variation of different those properties in the modern periodic table, the periodic table given by Moseley, which after certain changes came as modern periodic table. Now, first we consider some of the changes like electronegativity, atomic radius, electron gain enthalpy, ionization enthalpy, electronegativity, etc., etc. Now, how they changes? If you want to know exactly the change of those periodic properties, you have to know the screening effect of the screening. What is shielding effect? What is the shielding effect or screening effect? Now, already we have discussed what is screening or shielding effect. Now, in some detail, here you see that when you consider an atom, the atom, it contains the positively charged proton at the center and the negatively charged electrons in different cells. Now, if you consider what is the attractive force of proton over the outermost cell, then the outermost cell electron experience two different types of interactions. The number one is the attractive force by the proton on valence shell, and number two is the repulsive force by the inner electrons on valence shell. So the electrons in the valence shell, they experience two types of interactive forces. One type of interactive force, that is the attractive force, attractive in nature, where the proton attracts the outermost cell electron inward But the electrons in the inner cells, they want to repel the outermost cell electron to move outward. That's why electron is not totally attracted by the central nucleus. There is some sort of repulsive force also creates, and this type of repulsive force is known as the shielding effect or the screening effect, which decrease the attractive force of the central nucleus over the outermost cell electron. Now let me clear once again. The electrons present in the outermost cell, they experience two types of forces. Number one, that is the attractive force by the protons present at the nucleus. Those protons attract the outermost cell electron and tends to attract electron inwards. But the electrons in different cells, different inner cell, they wants to remove those electrons. There is some repulsive force over the outermost cell electron. So as a result, electrons are not that firmly attracted by the central nucleus due to the repulsive force of the inner electrons. And as a result, there is some sort of screening or shielding effect is occur, and this shielding effect decreases the nuclear attractive force over the outermost cell electron. Is it clear to you what is shielding effect or screening effect?
Yes, sir.
Vaidurjo?
हाँ सर.
अच्छा. Nirav?
Yes sir.
Okay. Urvi? Okay. So, as we already explained, that what is the shielding effect? Shielding effect which can decrease the nuclear attractive force over the outermost cell electron. Now, what is the effective nuclear charge? Now, what is the effect which inner electron should shield the valence electron from the attraction of the nucleus in the multi-electronic system? That multi-electronic system means those contains the greater number of electrons in the inner cell. The attraction between the outer electron and the nucleus decreases due to the repulsion with the inner electron, and those actually that means the shielding effect. Now, due to this shielding, the nuclear charge, much less amount of nuclear charge is operated on the outermost cell, and that can be calculated on the basis of a formula, that is the Z minus, this is shielding constant, this is shielding constant or screening constant. So if you subtract some amount of charge from the nuclear charge, that will be the effective nuclear charge. Z effective means the effective nuclear charge. What is effective nuclear charge? Effective nuclear charge means what is the amount of nuclear charge that goes the outermost cell. Now, if you consider like sodium, it contains 11 protons. Now, this 11 protons, Z is equals to 11. That is the nuclear charge. But what is the amount of nuclear charge that goes the outermost cell? That should be calculated on the basis of the fact that Z effective will be Z minus some constant value, that is the sigma. Now, if you consider, for example, if you consider the sigma value is 3, then the Z effective will be 8. So 8 protonic charge goes into outermost cell to attract the outermost cell electron inward. So Z effective will be less than that of nuclear charge or atomic number. So Z effective is the actual amount of charge that goes into outermost cell, and outermost cell attracted inward by those effective nuclear charge. I think this is clear to you.
So can you explain again
Which one?
the effective nuclear charge?
Now just see one point. That is the nuclear charge means how many number of protons present in the nucleus. That is, for example, if you consider this is oxygen. The oxygen, it contains Z equals to 8. So this is the nuclear charge or the atomic number. Now what is the effective nuclear charge? The effective nuclear charge means the how much amount of nuclear charge that attracts the outermost cell electron. Now if the Z is equals to 8 or nuclear charge equals to 8, then due to the shielding of inner electrons, then the effective nuclear charge will be less than that of nuclear charge by a fraction of sigma. If you consider that Z is 11, Z is here Z is 8, Z is 8, and the sigma has some constant value. That value may be here you can consider as 4. Then the effective nuclear charge will be 4. That is, the 4 protonic charge goes into outermost cell to attract it. So that's why you can say that effective nuclear charge is not equal to the nuclear charge or the atomic number. Effective nuclear charge means the atomic number minus some amount of constant, that is the shielding constant. If we subtract that amount of shielding constant from the nuclear charge, then you get the effective nuclear charge. So effective nuclear charge means what is the amount of nuclear charge goes into outermost cell after the shielding. After some amount of shielding, the rest amount of charge that is goes into outermost cell, that is known as effective nuclear charge. Now is it clear?
Yes, sir.
Okay. So now we move towards the different properties. First of all, we should discuss about the atomic radius. Now what is actually atomic radius means? Atomic radius means the distance of nucleus to outermost cell. Now think about the fact here. You consider if this is an atom, then the distance between this is nucleus and this one is outermost cell. So this is the radius of an atom. But the problem is that according to the concept of some scientists like Heisenberg or de Broglie, there are some scientists, they work different models of atom. They give us an idea that atoms do not have distinct boundary. They do not have the boundary like this. The atoms contains some diffuse charge cloud. Here you see some diffuse charge cloud. Electrons are the diffuse charge cloud. Electrons do not move in a particular orbit or in a definite shape of orbit. They move in a diffused manner. So there is no sharp boundary of an atom. That's why it is quite difficult to determine the radius of an atom. This is the one important thing. If you want to calculate what is the radius of an atom, then it will be very difficult for you to calculate the radius of an atom. only because of the fact that atoms do not have sharp boundary. Atom is not like that, not like that, like not like this. This is radius. Atom is actually like this. This is the diffuse charge cloud. Electron can be present in any of the part of this charge cloud. So it will be quite difficult to determine what is the actual radius of an atom. Again, another important fact is that the isolated atom is impossible. For example, if you consider oxygen, then existence of oxygen atom is impossible. So when you get oxygen, then you should get O2, or even you should get Cl2. You never get chlorine atom. So because of the fact that you do not have any isolated atom, then how will you calculate its radius? So these are the problem in determining the radius. Again, if you consider that it has diffuse charge cloud, then when you get the size, that size will be like, the value will be like this, 1.2 into 10 to the power minus 10 meter or even greater, because of the fact that there is no defined boundary for an atom. So because of the fact that there is no sharp boundary of an atom, it is quite difficult, or the any measurement you made, those measurements should not be accurate. So according to scientists, they determine radius in a different way. How they determine radius? Here you see some of the process by which they can determine the radius. Now here you see that it is the distance between, primarily it is the distance between nucleus of an atom and the outermost cell electron, but the exact determination of atomic radius is not feasible due to the difficulty in isolating an atom, because atoms are not isolated. If you consider inert gases, then in case of inert gases, they contain isolated atom, but in other cases, isolated atom should not be formed. That's why it is quite difficult to determine the radius of an atom. Now, if the atoms are bonded together, for example, if you consider chlorines. Now, in case of chlorine, actually you get chlorine molecule. Okay. Actually you get chlorine molecule. This one is chlorine atom and this one is another chlorine atom. And they are bonded together. So the radius will be, you can determine the internuclear distance. This is the internuclear distance. This is the internuclear distance. Distance between the nucleus of two atoms. Okay. Now this internuclear distance, suppose this distance is d. Then covalent radius will be d by 2. This is covalent radius when one chlorine atom or one fluorine atom, they bonded with other atom, then we determine the distance between two nucleus, and that is divided by 2 is known as covalent radius, like this. This is 2r, the distance between two nucleus. If you consider this is 2r, then the covalent radius will be 2r divided by 2, that is equals to r. This is the one technique by which you can determine the radius of an atom, because nucleus has some distinct position So you can determine the internuclear distance. There are so many number of instruments, so many number of instruments. Those instruments can be used to determine the internuclear distance. So internuclear distance can be easily determined, and divided by 2, you get the covalent radius. Now take an example where the chlorine atom is bonded with another chlorine atom, and the distance between them is 198 picometer. Here you see 198 picometer, and divide by 2, that gives the covalent radius. This is termed as covalent radius because they are covalently bonded. So covalent radius 198 by 2, that is near about 89 picometer. Now the variation of atomic radii across the period, that is, if you go from left to right, then what should be the change of atomic radius. Now here you see that as we move from left to right, in the periodic table, the size of the atoms gradually decreases. Size of the atom gradually decreases. As we move from left to right, size decreases in the period, and as we move down the group, the size of the atoms gradually increases. So left to right, size decreases, and down the group, size increases. But you never consider this type of changes in case of inert gases, because all those cases we determine the covalent radius. That means when the atoms covalently bonded with the other atom, then we determine the internuclear distance, and divided by 2 gives the covalent radius. But because of the fact that helium, neon, argon, krypton, xenon, they do not bonded with the other atom, they are monoatomic. So it is not possible that He2 or Ne2 or Ar2, this type of molecule is impossible. That's why their radius should not be determined by this particular method. Some other different method can be used. So the size of inert gases should not be compared with that of the other elements. Size of the inert gases always considered to be greater with respect to the other element, because of the, not because of the fact that they having greater size, but because of the fact that we have some inability to determine the covalent radius of those inert gases. We can't determine the covalent radius because they are not covalently bonded with other atom. Just think, chlorine is bonded with other chlorine atom, that is Cl2 is formed, and we determine the internuclear distance, and divided by 2 gives the covalent radius of chlorine. But do you get He2 or do you get Ne2? You never get this type of molecule. So how you should compare the size of fluorine with that of neon, or size of chlorine that of argon? You always see that size of helium, neon, argon, those elements having greater with respect to the fluorine, chlorine, bromine, iodine. But as we all know that as we move from left to right, the size of the different element decreases gradually. This is except the inert gases. Now, what is the cause behind it? Why the elements, as we move from left to right, the size decreases? Now, first, see the different values. If you do not consider the inert gases, then lithium, that is 152 picometer. After that, beryllium 111. You don't have to remember those values, but just comparison, you see that lithium is 152 picometer, Beryllium is 111 picometer, boron is 88, carbon is 77, nitrogen again decreases, oxygen decreases, and up to fluorine it is decreases. As we move down the group, that sodium placed below that of lithium having greater size 152 to 186, or beryllium to magnesium 111 to 160, like that. Here you see that fluorine to chlorine, that is 64 to 99 picometer. So as we move from left to right, the size of the elements decreases, and also down the group it is increases. Now, what are the factors those affect the atomic radius? Now, number one factor is the number of cells. Now, as we move down the group, why the size of the atoms increases? This is only because of the fact that the size atomic radius increases due to the increase in number of cells. Increase in number of cells. Now already we have discussed that the electronic configuration, if you consider lithium, sodium, potassium, rubidium, cesium, francium, then lithium has 2 cells, 2, 1. Sodium has 2, 8, 1. Potassium has 2, 8, 8, 1. Then after that 1. In this way, so outermost cell is farthest from the nucleus. Outermost cell number increases. As the increase of number of cells, the atomic radius increases, because number of cells is directly proportional to the atomic radius. The element having only K cell, smaller in size, element having L cell, greater, element having M cell, also greater. In this way, as the cell number increases, also the atomic radius increases. As we move down the group, number of cells increases, though their outermost electronic configuration is same, but because of the fact that number of cell increases, then atomic radius also increases. Now another factor that affecting the atomic radius is the nuclear charge. Nuclear charge, that means the number of protons. Now we can consider that the effective nuclear charge. Now as we move left to right, like lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, now 2, 1, 2, 2, 2, 3, 2, 4, 2, 5, 2, 6, 2, 7, they have electronic configuration like this. So all as we move left to right, that then number of cells not increases, number of cells are same. Number of cell is 2 in this case. Number of cell not increases, but the number of proton and the electron increases. So the effective nuclear charge over the outermost cell increases. Here you see, as we move from left to right, then what you see? That number of cells not increases. In case of lithium, the cell is 2, here also 2, here also 2. All the elements having the number of cells are 2. But as we move from lithium to fluorine, lithium contains only 3 protons, but fluorine contains 9 protons. So force of attraction, effective nuclear charge over the outermost cell increases, and due to this effective nuclear charge, the outermost cell contracts inward. And that's why you can say that as the effective nuclear charge increases, the atomic radius decreases. So, effective nuclear charge is inversely proportional to the atomic radius. As the effective nuclear charge increases, the greater amount of nuclear charge goes into outermost cell, and outermost cell electron contracts inward, and as a result, size of the atomic size decreases. So, the change of atomic radius from left to right, that is decreases, and as we move down the group, that is increases. These two factors explained in this way. Is it clear to all of you?
Yes, sir.
Yes.
Okay. So, how atomic radius changes from left to right and top to bottom, just we have discussed. Here you see that from lithium to fluorine, the cell number is same, but the effective nuclear charge increases from left to right, and as a result, size decreases. And as we move down the group, here you see that though there is increase of nuclear charge, but the cell number, as the cell number increases, number of cell increases, so in this case, atomic radius also increases. Here you see lithium, sodium, potassium, rubidium, cesium, francium. Also see the number of cells, like in case of lithium, that is equals to 2, but in the down the group, number of cells increases. Now we consider, already you have considered that the size, atomic size of different elements down the group and along the period. Now we consider about the ionic size. Ionic size means what is the relationship between the size of an atom and corresponding cation and size of atom and corresponding anion. So size of anion, size of the outermost cell, in case of cation or anion, is known as ionic radius. Ionic radius also changes in the same way, but first of all, we should consider what are the ions. Now here you see ions are formed due to loss or gain of electrons. Like here you see that this is parent atom. Parent atom means it contains equal number of protons and electrons. Now after the loss of electron, then proton number is greater with respect to electron. And this is known as cation, and cation will be smaller in size. Always cation will be smaller in size. Now why? Why cations are smaller in size? Now we consider sodium as an example. See, sodium, it contains 11 protons and 11 electrons. But when you remove one electron, then there is no change of number of protons, but electron number is decreased down to 10. So previously 11 electrons are attracted by 11 protons. But after the removal of one electron, 10 electrons are attracted by the 11 protons. That means greater amount of protonic charge that attracts the electronic cloud, because previously the attraction is 1:1. 11 electrons are attracted by 11 protons. But after the removal of one electron, then the 11 proton attracts 10 electrons. That means the attraction in case of sodium plus, that is the cation, in case of cation is greater than that of neutral sodium atom. And that's why you can say that size of sodium will be greater than that of sodium plus, or in other words, you can say that sodium plus is smaller than that of sodium, only because of the fact that there is more firm attractive force or more effective nuclear charge in case of cation than with anion. Now, the anions, here you see cations are smaller than sodium. Having, if you compare the size, that atomic radius of sodium is 186 picometer. Atomic radius of sodium is 186 picometer. But the ionic radius of sodium, that is the size of sodium plus, is 95 picometer. So there is high difference of ionic radius, near about half. Only removal of one electron, the radius of, just compare the radius of sodium plus and sodium. So you can say that cations always smaller in size than that of neutral atom. Now consider about the size of anions. Now what is anion? Anion means after the addition of electron or after the gain of electron, parent atom converted into anion. Like you consider Cl, it contains 17 protons and electron is also 17. Now chlorine gains one electron with the formation of Cl minus. Here also contains 17 protons and 18 electrons. So previously 17 electrons are attracted by 17 protons. But after the addition of one electron, the 17 proton attracts 18 electrons. So attraction per electron. Previously the attraction is 1:1. And here you see that 18 electrons are attracted by the 17 protons. So attraction is quite less than that of neutral chlorine atom. And not only that, previously it contains only 17 electrons, but now it contains 18 electrons. If a particular atom contains greater number of electrons, then electron repulsion will be effective. Electron repulsion will be effective. So because of the fact that this electron repulsion, the size increases. So anions having greater in size with respect to parent atom. So why anions are greater in size with respect to parent atom? Again I repeat, after the addition of one electron or two electron, maybe whatever may be the case, as the electron number increases, the protonic attraction or the attraction of nuclear charge per electron decreases. And not only that, there is some sort of electron-electron repulsion will be effective in case of anions, and that causes the greater size in case of anions. If you see that different values, then this repulsion is known as inter-electron repulsion. Inter-electron means, like here you see that fluorine, if fluorine takes another electron, then fluorine already contains 9 electrons, but after taking one electron, it contains 10 electrons. But fluorine has a very small size, and very small size fluorine, when accommodate an extra electron, then electron-electron repulsion will be effective, and that causes the greater in size in case of anions. So anions are greater with respect to the parent atom. Just see the values. Fluorine atom having atomic radius 64 picometer, but the fluoride ion ionic radius is 136 picometer, more than double. So after taking one electron, anions having greater in size with respect to the parent atom. So I think all of you are having clear this particular fact, that why cations having less in size with respect to the neutral atom, and why anions having greater size with respect to the neutral atom.
Yes, sir.
Okay. Anyone have any difficulty related to this fact?
No, sir.
No. Okay. Now we see some graphical representation. Graphical representation is not anything to explain. Here you see that that is a gradual increase in the size as we move down the group. So this particular graph define all those facts which we have already discussed, that how the atomic or ionic radius changes as we move down the group. So down the group, atomic or ionic radius increases. Now we move to next important property, that is actually this property, that is the atomic radius. We have already completed. Now next one, that is the ionization enthalpy, we should discuss. But before that, we do some practice questions. Now practice questions, like first of all, we discuss some isoelectronic species. Now what does it mean? Anyone have any idea about the isoelectronic species? Do you have any idea what is isoelectronic species? Isoelectronic species, what does it mean?
Sir, ions যাদের same number of electrons থাকে.
Different ions or the neutral atom may also be having different number, same number of electrons, like N3 minus, O2 minus, F minus, neon, sodium plus, Mg2 plus, aluminium 3 plus, like that. Proton, it contains 7 proton, it contains 8, 9, 10, 11, 12, 13, and electron, that is equals to 10, because it contains 7 electrons but 3 minus, that is equals to 10. Here you see that it contains 8 plus 2, that is equals to also 10. 9 minus 1, that is equals to 10. Now here no charge, that is 10 equals to 10. And sodium 1 positive, that is equals to 10. That 12, 2 positive, that is equals to 10. And aluminum 3 positive, that is also equals to 10. Now you see that isoelectronic means different species. Like here we write different species like N3 minus, O2 minus, F minus. But all those different species contains same number of electrons. That's why they known to be isoelectronic. Iso means same. Iso, this particular word means same. Isomer, isoelectronic, isotone. That is iso means same. So isoelectronic species means the different species having same number of electrons. Now, if we want to consider which one having smallest size in this series, which one having smallest size, which one having smallest size, N3 minus or O2 minus, F minus or L plus 3, which one is smallest size?
L3 plus.
L3. Can you have any explanation?
হ্যাঁ, কারণ ওতে মানে সবথেকে কম অ্যামাউন্ট অফ ইলেকট্রন আছে, তাই জন্যই মানে যেই
amount of electron number is same. Already you have mentioned that electron number is same.
ও হ্যাঁ, না প্রোটন গুলো সব থেকে বেশি আছে, সরি, মানে রেশিও অফ অ্যাট্রাকশনটা বেশি হবে, তাই জন্য ছোট হবে।
Okay. Let me clear.
মানে 1.3 হবে, 1.2 হবে, 1.1 হবে, মানে কমতে থাকবে।
So if you consider the atomic size or ionic size of this species, then because of the fact that they all contain same number of electrons, so you have to compare the number of protons. Now, as aluminium plus 3 contains greater number of protons, so proton to electron ratio is maximum in case of aluminium plus 3. And that's why you can say that attractive force of attraction of proton over the electrons greater, and as the attraction, or already you have mentioned that effective nuclear charge over the outermost cell increases, then the size also decreases. So size order will be like this. This is the size order like this, where you see that N3 minus will be largest in this series and aluminium plus 3 will be the smallest. So very good. The size order can be explained in this way. Now the practice questions. Now, decreasing order of first one, that is the decreasing order of atomic radii. This one is I minus, I and I plus. So already you have mentioned that cations having smaller size with respect to the parent atom and anions having greater size with respect to parent atom. So the order will be I minus, I minus maximum. After that I and I plus will be smallest. Now, what should be the order of size in the second one?
Ca2 plus, Mg2 plus, Al3 plus.
Ca2 plus will be maximum. After that Mg2 plus and aluminium 3 plus. Mg2 plus and aluminium 3 plus, they are isoelectronic. So explanation why the magnesium 2 plus having greater size with respect to aluminium is already we have explained. That aluminium plus 3 it contains 13 protons, and magnesium 2 plus it contains 12 protons. But calcium having greater size because it contains greater number of cells, because calcium contains greater number of cells with respect to magnesium and aluminium. That's why calcium is largest with respect to magnesium, and magnesium is greater than the aluminium. So okay, yes, this is very good. Now the first one, O2 minus, sulfur 2 minus, and Ac2 minus. What should be the expected order of atomic radii?
স্যার AC2 মাইনাস কি সব থেকে বড় হবে?
Ac2 minus is maximum
হুম,
because
মানে ওটা মানে গ্রুপ মানে ডাউন দ্য গ্রুপ এবং অ্যাক্রস দ্য পিরিয়ড।
it placed down the group, so from top to bottom you see that oxygen is above all the elements having 2 minus, so that is not so comparable. 2 minus, all the elements having 2 minus, so that is not considerable. Consider the position of the elements, that is down the group. So oxygen is smallest, after that sulfur 2 minus, so selenium 2 minus will be greatest size because it placed below that of oxygen and sulfur. Now the next one, that is also isoelectronic species. This is also isoelectronic species because S2 minus
স্যার তাহলে S2 মাইনাস, তারপরে Cl মাইনাস, তারপরে K প্লাস, তারপরে Ca2 প্লাস, তারপরে Sc3 প্লাস।
S2 minus, Cl minus, all those ions contains same number of electrons, but in this series they contains greater number of protons. Can you say the order of these elements like this? I think this is quite difficult for you. Let's see.
স্যার K লার্জেস্ট হবে,
Which one is largest?
পটাশিয়াম,
Potassium.
potassium,
সোডিয়াম,
smallest
তারপরে
fluoride,
অ্যালুমিনিয়াম, তারপরে সিলিকন, তারপরে
silicon,
কার্বন, তারপর নাইট্রোজেন, তারপর
nitrogen,
ফ্লোরিন।
Sodium, aluminium, silicon, potassium. Potassium is maximum. Potassium is maximum. Below the down the group increases. So potassium is maximum. After that sodium. After that aluminium. Then silicon. Left to right decreases. So carbon. After that nitrogen. Then fluorine. In this way, increasing order of atomic radii, F minus, Cl minus, Br minus, and I minus, it is quite easy because down the group, fluorine, chlorine, bromine, iodine. As we move down the group, size increases. Negative or positive is not so important because all the elements contain same negative charge. Identify the correct order of size. Which one is correct order of size? They are also isoelectronic species.
The first at
First
So
one,
A,
S2 minus, S2 minus, all those species contains 18 electrons. But calcium contains 20 protons, whereas sulfur contains only 16. So the order will be calcium 2 plus, potassium plus, argon and Cl minus, S2 minus. Like this. So easy. Correct order of atomic radii in the group 13. Now, the one exception is here. That is, as we move down the group, size increases. But in group 13, there is some exceptional fact that boron, aluminium, gallium, indium, thallium, but the size order is the gallium and aluminium, they changes their position. So boron is less than gallium and after that aluminium. So aluminium and gallium, they changes their position. So the correct answer will be option D.
B.
Boron, gallium, aluminium, indium, thallium. This is the correct order. This is another easy one.
Sir, B.
Option
B.
Option B. Very good. Option B. Because isoelectronic species. So isoelectronic species is very important. Can you say what is the correct option in this case?
Sir, A.
A.
Now fluorine and neon. Fluorine, already we have mentioned that halogens and neon having greater size because of the fact that we don't have any literature value of neon having covalent radius. This is fluorine. So
স্যার
fluorine
নিয়নে কি রেডিয়াস ক্যালকুলেট করা
নিয়নে যে রেডিয়াস ক্যালকুলেট করা হয়, that is actually known as van der Waal radii. And what does it mean, van der Waal radii? Just consider this is neon and the closest approach of another neon. This is the closest approach of another neon. Now we take the internuclear distance and this internuclear distance divided by 2 is the radius. Now because of the fact that neon and neon, they are not bonded with each other, so their closest position is very much greater with respect to the covalent bond in other cases. In case of covalent bonded, they are very close enough. So their distance between internuclear distance divided by 2 is not quite comparable with the van der Waal radius, because van der Waal radius is always greater. Only because of the fact that in case of van der Waal radius, we consider the atom's closest approach. Now, if they do not bonded with each other, then they do not come closer. Only because of the fact that they are electronic cloud, they repel each other. So those atoms do not come closer. So they fixed at a particular distance. Then we determine the internuclear distance and divided by 2 is actually van der Waal radii. Now van der Waal radii should be much van der Waal radii is much greater than that of covalent radii. So van der Waal radii will be greater than that of covalent radii only because of the fact that they do not come closer due to the electronic repulsion of the external electronic cloud. Is it clear?
হ্যাঁ স্যার
So that's why we never compare the atomic size of inert gases with that of other elements where we consider the covalent radii. So here the first one is the correct answer because the neon having greater size with respect to fluorine. Now the next one. Now here we consider. Now what is ionization energy? What is ionization energy? Ionization energy is the amount of energy that is required to remove an electron from the electrons in the outermost shell. Now just consider this is an atom. Okay, this is an atom. It contains nucleus and the different cells. Now the electrons present, the different cells should be attracted by the central nucleus. But the electrons present in the outermost cell, should be considered as loosely bound. Loosely bound means those electrons are not firmly attracted by the central nucleus due to the distance factor. The electrons are very close to the nucleus, they are well attracted by the central nucleus. But the electrons which are farthest apart from the central nucleus, those electrons are much less attracted by the central nucleus. So energy given to remove that electron is actually known as ionization energy. So first important thing is, what is the ionization energy? It is the minimum energy. It is the minimum energy required to remove the most loosely bound electron. Which electron? Those electrons which are present in the valence shell. So the electrons those are present in the valence shell are most loosely bound, and if you want to remove that electron, the energy required is known as the ionization energy. Now two important points are there. One is the isolated gaseous atom and another one is ground state. What does it mean? If you want to remove electron from an atom, you can't do this when the atoms they are attached with each other. That will be difficult to remove an electron. So first thing, you have to isolate those atoms like this. So the element should be converted into gaseous state. In the gaseous state, the atoms are isolated. Now another important term is that ground state. What does it mean? Ground state means an element contains its electrons in different cells. Like if you consider hydrogen, it contains only one electron in the first K cell. This configuration is known as ground state. Ground state means where the electrons are in most stable state. Now, if you supply some energy to this outermost cell electron, the electron may jump lower to upper energy level. Like electron maybe jump from K cell to M cell. And this configuration, the change configuration is known as excited state. So there are two types of electronic configuration of any electron. One is ground state. Ground state means most stable state. It contains the electrons in most stable orbit. But after you apply some amount of energy, those electrons jumps to lower to upper energy level. That is known as the excited state. Now, in case of ionization energy, electrons should be removed from ground state. So ionization energy, what is ionization energy? It is the minimum energy required to remove most loosely bound electron. That means the electrons present in the outermost shell from an isolated gaseous atom in its ground state. Like this, M is an atom in the gaseous state. So some energy is given to the system, in order to remove this electron. So M is converted into M plus. So the amount of energy that is given is known as ionization energy. The unit of ionization energy is kilojoule per mole or kilocalorie per mole or electron volt per atom. These are the units because the ionization energy is the energy term. That's why we should use the units of energy. So we just discuss up to this particular topic, that is starting of ionization energy. Next day we should complete this particular chapter. And not only that, one important जो बातें हैं वो बोलना है. From next day we should, each and every day we should start with some 15 MCQ questions. ठीक है, 15 MCQ questions like previously we did that in class 9. Those 15 MCQ questions, having all those questions having 4 marks each for correct answer and -1 for wrong answers. So we prepare a question paper, MCQ type question paper. Those contains only one correct option. Next day we take some MCQ questions up to atomic radii. Now we have not completed ionization energy, so just we start the ionization energy. So I can't give any question related to ionization energy, but we should give some questions related to the silent features of modern periodic table and also the atomic radii, which we have discussed today. And from next day we should consider this type of exam in each and every day, and we give only 15 minutes for 15 questions. Okay, so we should start this type of MCQ questions for all of you from next day. Okay, তো আজকে এই পর্যন্ত থাকলো. পরের দিনকার আমরা আয়নাইজেশন এনার্জি থেকে কন্টিনিউ করব, আর এক্সামের কথা যেরকম বললাম সেরকমই করব. ওকে, থ্যাংক ইউ সবাইকে. গুড নাইট.
গুড নাইট. থ্যাংক ইউ.
Bye.